So let's take a look at the first question for grade 6 term 2. Yana uses tiles to build V-shapes as shown above. Which V-shape will need 101 tiles to build? My first step is to determine how many tiles are in each term. For V1, there are 3. For V2, there are 5. For V3, there are 7. And for V4, there are 9. Therefore, how many tiles am I adding between each shape? 2. I'm adding 2 tiles. So what would my rule for this geometric pattern be? I could say V times 2. Now let's see if there's something that I need to add to my rule. So V1, which is 1 times 2 is 2. But I've got 3 tiles in V1. Therefore, I still have to add 1 to my rule. Let's see if it works for V2. 2 times 2 is 4, plus 1 equals 5. So my rule is correct. Now let's answer the question. Which V-shape will need 101 tiles to build? So grade 6's, what do I have to do? Yes, I have to do the inverse. 101 minus 1 divided by 2. And that will give me 50. Therefore, V50 will need 101 tiles to build. Let's move on to my second question. Tandi builds a pattern of cubes as shown. How many cubes will there be in pattern 20? So let's find out how many cubes are in each pattern. And don't forget grade 6's, these are 3D shapes. In pattern 1, I have 1 cube. In pattern 2, I have 4 cubes. And in pattern 3, I have 9. So how am I going to determine how many cubes there will be in pattern 20? Well, I could draw all the patterns up until pattern 20 and count my cubes. However, there has to be an easier way. Do you see a relationship between your pattern number and the number of cubes? I could say that the pattern number times by itself will give me the amount of cubes. For example, pattern 1, or simply 1 times 1 would give me 1. What about pattern 2? Well, 2 times 2 would give me 4. And pattern 3, 3 times 3 would give me 9. Or I could simply say 1 squared, 2 squared, and 3 squared. Therefore, using this rule, how many cubes will there be in pattern 20? Well, I could simply say 20 times 20, or 20 squared. And that would be equal to 400. Therefore, in pattern 20, there will be 400 cubes. Let's move on to question 3. The number pattern above is called Pascal's triangle. What is the missing number at A? Well, each number is the sum of the two numbers above it. For example, 1 plus 1 equals 2. 1 plus 2 equals 3. 3 plus 3 equals 6. 4 plus 1 equals 5. 6 plus 4 equals 10. And 10 plus 10 will give me 20. Therefore, the missing number at A is 20. Let's answer question 4. What is the number indicated by A on the ruler? Well, in order to do this, we have to determine what each line represents. Therefore, I know that this length has to equal 0.10. And I have 1, 2, 3, 4, 5 increments. Therefore, 0.10 divided by 5 will give me 0.02. Therefore, each line equals 0.02. I could number my ruler as such. 4.12, 4.14, 4.16, and 4.18. A has to be 4.10 subtract 0.02, which should give me a total of 4.08. Therefore, A is 4.08. Let's move on to question 5. A lorry with a load of maize has a mass of 4,653 kilograms. The mass of the empty lorry is 2,583 kilograms. One bag of maize has a mass of 90 kilograms. How many bags of maize are on the lorry? So I know that a lorry with a full load of maize has a mass of 4,653. I also know that an empty lorry has a mass of 2,583. To calculate the mass of the maize, I need to subtract 2,583 kilograms from 4,653 kilograms, which would give me a total of 2,070 kilograms. I also know that one bag of maize has a mass of 90 kilograms. To find out how many bags of maize on the lorry, I need to divide 2,070 by 90. So 90 can't go into 2, it can't go into 20, but it can go into 207. And it can go into 207 twice. 90 times 2 is 180, 207 minus 180 gives me 27. 90 goes into 270 3 times with no remainder. Therefore, there are 23 bags of maize on the lorry. Question 6. Theo spends half of his pocket money on computer games. He uses 1/8 to buy sweets and saves 1/8. He has 15 Rand left. How much pocket money did he have? So let's look at what Theo has already used. He's used half of his pocket money on computer games. He's used 1/8 to buy sweets. And he's also saved 1/8. Well, firstly, let's determine what Theo has already used. He's already used a half of his pocket money on computer games, 1/8 to buy sweets, and he's also saved 1/8. The first thing I have to do is I have to find a common denominator. In order for all of these fractions to have a denominator of 8, I have to multiply my 2 by 4, and I do exactly the same with my numerator. I multiply it by 4. Therefore, my fraction would read as follows: 4/8 plus 1/8 plus 1/8, which will give me a total of 6/8. I can simplify this fraction by dividing both the numerator and denominator by 2, which would give me 3/4. So I know that Theo has already spent 3/4 of his pocket money. The 15 Rand that he has left is equal to 1/4 of his pocket money. 1/4 of his pocket money is equal to 15 Rand. 4/4 or a whole of his pocket money would be equal to 4 times 15, which would give me a total of 60 Rand. Does this answer my question? How much pocket money did he have? Yes, it does. Theo received 60 Rand pocket money. This brings us to our bonus question. When Joe was 5 years old, Diana was 8. When Joe was 8, Cindy was 6. How old was Diana when Cindy was 8? Well, I know that Diana is 3 years older than Joe, and Joe is 2 years older than Cindy. Therefore, Diana is 5 years older than Cindy. So when Cindy was 8, Diana was 5 years older, which made her 13 years old. And this brings us to the end of Mathematics Smarts, Grade 6 for Term 2.